So my name is Lindsay Miller, and I found out about this program because Dave Young, who's one of the co-founders of this organization, we went to college together. He was actually my TA in circuits class in college. So he told me about what he was doing, and I thought it sounded really cool. So I'm glad I get to come talk with you guys. If you have any other questions that pop up, just raise your hand and I'll write them on the board so that we're sure to address them. Otherwise, I thought I would just describe kind of my path from high school to where I am now, and then I brought a small little thing to show you. It's thermoelectrics, which is something I work on now. And otherwise, I'll tell you, like why I became an engineer and what I like about it, and tell you some about what I do every day as an engineer. So first of all, in high school, I guess, and this goes back to how I became an engineer. Probably like a lot of you guys, I was really interested in physics, and I loved all my science classes, and just really loved learning how stuff works and why it works, and learning equations that describe all of it. So that led me to be interested in something like engineering, but I really had no idea what an engineer does. I couldn't have told you 3 things that an engineer would actually do if you follow that career path. So then what really made up my mind to become an engineer was I went on this kind of a day camp to University of Cincinnati when I was going into my senior year in high school. And so each day we went to a different engineering department, and it was here's what electrical engineers do, here's what mechanical engineers do. And after that I was like, yeah, that's awesome, I want to be an engineer. So then I took AP Physics and stuff like that in high school, and applied to schools for engineering, and ended up going to Case Western in Cleveland, and that's where I met Dave Young, and Robin too, but I didn't know him as well in college. And then while I was at Case Western, I interned for 2 summers at Procter & Gamble, and I worked in the Always division, so they make female products, sanitary pads, and at first I was really unexcited about that assignment because you don't get to pick, they just assign you to an internship. But it actually ended up being very cool, and there was a lot of really interesting science that goes into those kind of things, like fluid mechanics and absorbent materials and things, and then learning about how they manufacture all of it on big lines, and just pads flying off the line, pew, pew, pew. It was really interesting. And so that was 2 summers that I spent interning there, and I really liked it and learned a lot, but I didn't want to work I didn't think it was really what I wanted to do long term. I didn't think for me that would inspire me every day to go in and work on consumer products. So then for 2 summers I interned at NASA in Cleveland. There's a research center there called Glenn Research Center, and they focus on microgravity and combustion in space, things like that. I don't know if you've ever seen a picture of a candle burning in space where instead of it being a flame that goes up, it's a perfect hemisphere of blue flame around it. It's really cool. So fire acts different in space. So anyway, when I was there, I worked on studying, the first summer that I was there, I worked on studying the sort of interfaces between liquids and gas, between a liquid and air above it, that kind of interface. And honestly, that summer was terribly boring, and I hated it, and I actually almost thought about quitting engineering because I was this is terrible, I can't be an engineer if this is what it means. And luckily I stuck with it because that was just sort of not an assignment that suited my personality very well, because I was alone in the lab all the time and didn't really have any mentorship or I don't know, anything like that. And so then the next summer I got to work on a much cooler project, which was figuring out how to mix lunar soil really well. So I worked with a lunar soil simulant, so it's not actually lunar soil, but it behaves like lunar soil, and they're interested in studying how it mixes so they can learn how to heat it, because they're interested in extracting useful things like oxygen or materials for fuel or food from soil on other planets. So that was cool because I got to, that was a much more interesting project. I worked with people more closely, and it just sort of captured my imagination a lot more. So that was good. But I still, after those experiences, I didn't feel like I wanted to go work in a big company, an industry, and I didn't feel like I wanted to go work at a national lab or NASA, which was kind of heartbreaking because I always had wanted to work for NASA. That's what I thought I wanted to do, and then turned out it didn't really suit me very well. So then I decided to go to grad school because I really loved learning I really loved learning in college, and I felt like I would be interested in research. So I ended up coming out here for grad school to UC Berkeley and got my master's and PhD there, and also in mechanical engineering. And my research while I was there was on harvesting small amounts of power from mechanical vibrations. So like if you have a fan or a motor or an engine, it vibrates and you can like touch it and feel that it's vibrating. And I was working on how to harvest that energy in the vibrations and turn it into electricity. So that was a very cool project. It was the sort of larger application for that was for powering wireless sensors. So like all the stuff you guys are working on, it's all battery powered, and the idea would be to replace those batteries with the energy harvester, or integrate an energy harvester to constantly recharge the batteries so that you don't ever have to change the batteries. So that has like applications in energy efficiency, sensor networks, and you can imagine if all of these sensors and things were just powered by energy harvesting, it would be very cool, a lot of cool applications. So that's what I did in grad school mostly, and I also got to do a consulting project for Marin County where they wanted to know if money didn't matter, how much power could we get from renewable energy resources in our county. So I looked at like how much, theoretically, if you didn't care about money, where could you put wind turbines and how much power could you get from that? How about solar panels? How about off-sea like wave energy harvesting, stuff like that? And gave them a big report about what is the resource and what kind of power could you get out. So that was also very interesting. And now I work at a startup called Alphabet Energy, and we work on harvesting heat and turning that into electricity. So it's kind of similar to my grad school work in that I'm trying to harvest wasted energy and turn it into something useful. But in grad school I worked on microwatts and milliwatts, like very small amounts of power. And now I work on like kilowatt scale, like very large scale harvesting of waste heat. So for example, in steel manufacturing or in a power plant or in any of these industrial settings that have really hot exhaust air, our systems take that hot exhaust air and generate electricity from it. So that's how I became an engineer working at this startup. And let's see, I brought some thermoelectrics to show you, but so I guess I'll pass those around. Do you guys know what thermoelectrics are? Are you familiar? Anyone
Actually, I have a student in the AM section who's using DEGs for his project.
Oh, perfect. Well, then these are probably what that student is using.
Yeah.
So the way that these work is the material, they're special materials that have a property that when you apply a voltage to it, it makes current. So when you apply a temperature difference, it makes voltage. So what I'm going to show you is, you'll need to do this in pairs, I guess. So somebody hold the battery and just put the leads on the battery, and you can touch it, it's not a big deal. And then you'll feel one side get hot and one side get cold. Just don't do it for too long because it'll get really warm. And then you can flip the leads and see that the other side gets hot and cold. Like it only takes a second, I can feel it right now. So that's because, and these are commercially available devices, these are not ones that our company made, but we're working on making like large scale systems like this. In your car, the seat heater, or your parents' car, whatever, the seat heater that you push a button and the seat warms up, that uses thermoelectrics to do that. So I'll pass this around, and you can either like hold it on there yourself or get somebody to help you. But it sort of gives you an idea how quickly these things can work. Anyone have questions so far? Anything else you want to know more about?
How much power can one of those output?
Those is like a couple milliwatts. It depends on the temperature gradient on the different sides. So the cool thing about thermoelectrics is they can operate in two ways. You can either put that type of thing in so that one side is hot and one side is cold, and then it produces voltage. Or you can apply a voltage like the battery's doing, and it makes one side hot and one side cold. So the seat heaters work as like the inverse of what our company is trying to do. You can use it as like cooling and heating devices or as a power generation device. And in grad school, the materials I used to harvest energy from vibration were similar in that you could use them either way, where they were called piezoelectric materials. Some people might have heard of that. So in those materials, when you bend them and strain them, they produce a voltage. Or if you provide a voltage to it, it bends. So you can use them as motors, like linear motors, where you put a voltage on it and it actuates. So like in the tip of a disk drive in your laptops, the very fine motion to read and write on your disk drive, the tip is controlled by a piezoelectric motor because it can control very finely the motion. So that's kind of cool. Any other questions about anything so far?
How did you learn what you really wanted to work on after experiencing different things you do?
You just try each thing and see if it inspires you. I think like pay attention in class to what like really sparks your attention, where like the time just flies by and you're just like you don't even, you know, it doesn't feel like you're doing homework. It's just so interesting, like you're just interested to read about it, that kind of thing. But you just try a lot of different things. And I mean, one of the cool things about being an engineer is that there's a huge variety of things you can do. Like you can work on everything from rockets to sanitary pads, like and anything. And it gives you a whole lot of opportunities. Like you can take it in the biomedical direction if you're interested in like medicine or biology. You can take it in the construction direction if you're interested in big civil infrastructure, civil engineering, earthquake safety, you know, machines, and like just anything you can think of, electronics, like. So I think that's the exciting thing. And after doing my PhD for 6 years in the same research topic, I was bored of that topic, so I got to switch to a new topic for what I do now, which is so from harvesting from vibration to harvesting from heat. So it's always exciting. There's always more to learn, and you just have to keep trying different things until you find something that fits right. So that's one good reason to do internships or projects like these are great. You can see like, oh, do I like programming, or do I like putting things together? Do I like building circuits? Or do I prefer the kind of mechanical design of figuring out how all the components fit together? So every project can give you insight to that. So I thought I'd mention like kind of what I do day to day right now, and how it's different than grad school, for example. And again, stop me if you have questions. But in grad school, the things that were wonderful were that you have kind of infinite time to ponder your project and work on your research, and it's mostly more alone. Like it's mostly everyone has their own research project to get their own PhD, and sometimes you get really stuck on a problem for a while, but when you figure it out eventually, it's really great and it feels wonderful, and then you end up making something and, you know, publishing papers on things that have never been figured out before. So it's very rewarding in that sense. And the trade-off is that it can be kind of lonely. And so it depends. Some personalities do really great doing independent research. Some personalities prefer a team environment. And so I think, you know, I like both, but I prefer, I really liked the research that I did, but I also really love working on a team. And now my job, every day, I work very closely with dozens of people. Like our company is only about 24 people right now, so you know, but every day I work closely with a handful of them all the time, and it's like very rare that you're doing work kind of alone. So it's neat that also in engineering you can kind of choose based on your personality if you want more of a solo position or more of a team-driven position. So what I do now is I'm a process development manager at Alphabet Energy, and what that means is I work on kind of coordinating the team that works on the materials that go into our thermoelectric system. So like as you guys are passing it around, feeling it get hot and cold, it's the materials in there that make that happen. And so we work on developing new thermoelectric materials and then figuring out how to make lots of them in a way that's controllable for manufacturing process, and then how to reduce the cost, and how to, you know, then another big thing of what I do is how to not only make those materials, but then put them into the system. So assemble them. They have to get metal on both sides for the electrodes. They have to then get put into the full thermoelectric system. And so I work with a lot of people on coordinating all of that kind of stuff. Then, so at our company we're split into kind of the materials team, which I'm on, and then a system design and building team. So those are the people who would take the material that I deliver to them and make a big thermoelectric, make those little modules, and then make a big system with heat exchangers and everything like that. Then we have a couple of marketing people, and so that's basically it. So some days I work on things like reading papers from the academic literature to stay up on the latest thermoelectric material developments. Last week I went to a conference on thermoelectric materials, so those are very academic parts of my job that I really like, and that those are things that without having a PhD, it would have taken me a lot longer to get to a point where I can do those things, so that's what is useful about having the PhD. And then I also work on things like intellectual property and submitting patents for when we invent things, and I work on, like I mentioned, scaling up. So if you can make it in a small batch on the bench top, that's great, but then you need to be able to make tons of it for the system. And then at a startup, the cool thing is you do get to do lots of different stuff because of necessity. So like, I learn how to take care of facilities things, like how to get nitrogen gas from over there to over there where we need it, or how to fix the chiller when the chiller goes down, or other kind of machine maintenance things that are not really my job description, but it's kind of fun to learn and do different things. Like some days I take out the trash, other days I do like high-level research. So I do a lot of writing experiments and coordinating a team to execute the experiments, and then analyzing the data that comes back from that to improve the materials. So that's sort of a couple of things that I'll do day to day. But yeah, it can vary greatly depending on what type of position you have. If it's at a large company, it's probably a more stable job, but maybe more a specific job definition. At a startup, there's a lot more uncertainty, but you get to do a lot more things, and so just depending what each of you like, those are sort of, you get to figure out for yourself what fits you.
So like when you're interning and stuff, you say you don't get much choice in doing what you want to do. So how about in your job? Like, did you have all freedom to choose whatever you wanted to do?
That's a good question. I'd say when you first, it depends where you intern. Sometimes you do get to pick a little bit more what you're doing. Sometimes also once you've been there for one summer, the next summer you have some say in what you do, that kind of thing. So I would say a lot, and similarly with a job, you can apply to a job with a specific job description, but typically once you're in a job, if you want to shift to a different role, you have to just be vocal about it. You have to, talk to your managers and talk to the people on your team and take on new projects that are in a different area, and just let people know that that's what you want. And then usually companies want to keep you around, so they try to find ways to make sure your interests are being satisfied, and so you often get to move around in what you're doing as long as you say what you're interested in. Yeah.
Did you not like working in NASA because you were working like all alone? It was like a really big company?
That's a really good question. I didn't like working all alone. I definitely am a person who I like a couple hours of working alone, and then I like to work in a team. So if I'm alone all day, every day, I get very sad, and it's not a good job for me. But some people are different. Some people love just having the whole lab to themselves and just like zone out, and like that's what they like. So being alone was the biggest thing I didn't like. I actually was considering a job offer at Jet Propulsion Lab when I decided to go to Alphabet Energy. So I was very seriously thinking about going back to work at NASA, but it was the team I would have worked on there is the one that did the Mars rover. So, and I got to see the twin Mars rover. Like, they sent one there and then they keep one there so they can do testing on it and stuff. And that was like my dream come true. I got to see it. But if I'd worked there, I think I would have been a lot happier than when I first worked at the research center in Cleveland. Part of it also, though, is at a large government lab, there's more bureaucracy and things move slower. And that can be okay, like that doesn't necessarily mean you're unhappy, it's just a trade-off of that kind of thing. You mean, I would have been doing very awesome research at Jet Propulsion Lab and building really cool robots and systems and things like that, but it would have been a much slower time frame. Like today, if I need to order something expensive, all I have to do is turn my head to the left and holler like 10 feet that way, and then I get permission, and then I order it. Like, everything happens really fast and efficient at a small startup, and that's kind of that. I find that really exciting and fun. So that's kind of how I made that decision. And also, at a startup, you get to have a lot of say. Like, even if the CEO doesn't come to me and say, Lindsay, what do you think I should do about this latest marketing decision? That's not my job. The marketing team decides that. But if they update the team on what they're doing and I have an opinion, I can go tell them and say, I really think you should look at this market or something, and they'll consider it. Like, you definitely have a lot more say at a small company compared to at a big research center like NASA or at a big company. A lot more is kind of handed down the chain and decided too far away from you to have an impact. So there's just trade-offs. Like, each person finds a fit that works better for them. And I really like the people I work with, so if I worked at another startup that had people I didn't like, I probably wouldn't like it. So it's just gotta try stuff. Yeah.
I think you were mentioning this, but what engineering degree do you have? And like, you seem to be have a lot of variety in the different jobs that you have. How do you think like all engineering degrees have that same like variety of things that you can do? And then also, do you work with all the same type of engineers, or like a variety of types of engineers?
Good questions. Yeah, my degrees are both in mechanical engineering, and but in grad school it's very much more specific. So you get to pick which classes you take a lot more, and you get to pick a research project that ends up giving you a certain skill set. And so my skill set within mechanical engineering in grad school ended up being very materials based, and I took a lot of classes on materials, a lot of classes on clean technology, so everything ranging from actually like clean technology markets in the business school to a class on solar panels and how solar cells work. So you can pick and kind of hone your skills a lot more. I also took classes on design and manufacturing because those are things I'm interested in too. But yeah, I mean, with mechanical is probably the broadest field, but electrical is also very broad with what you can work on. I think really, I know a lot of people who've done equally diverse, different types of jobs in their career, and some people like that. Other people find the one thing that they love doing, and they want to be the expert at that one thing for their whole career, and that works too. So I'd say maybe half and half. Yeah. So I think it's a lot more of a personal decision and how much you pursue jobs. And it's maybe harder to get a job that's slightly outside like any background that you've had before, but you can do it. And also things like the connection to the job I have now from what my PhD background was in is that I had experience in clean room fabrication from grad school. Or do you know what that is? It's like if you see pictures of people in bunny suits, like the white head to toe, like Intel or IBM making like silicon wafers. You know what I mean? Some nods. Yeah, like so the people they're like in the full-on bunny suit and they've got the glasses and the safety and they're using tweezers and they're making basically computer chips on silicon wafers. I did that kind of thing in grad school to make my devices, but it was called MEMS, micro electromechanical systems. So that was a connection to the job I have now, because initially we were doing some clean room stuff, and that's why they hired me. But now I do a totally different thing. So that goes to what you were saying. I basically said, like, yeah, I'm really excited about this company, but I'm tired of working in the clean room. I want to, do something different. And so when things became available, I shifted to those things. So I think it's a lot of like, it's